So hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome. Today we're diving into ELITE's biggest hurdle, adaptability. So we'll uncover how the SEAL method enables models to learn autonomously in dynamic environments, so addressing current limitations. So join us to explore its potential for scalable, self-adapting AI and the challenges it faces. Can you explain the limitations of current AI models in terms of their adaptability and how these kind of limitations impact their performance in real-world applications?
Current AI models have a significant limitation when it comes to adaptability, much like a toy robot that can only follow the same set of instructions over and over again without learning anything new. So these models struggle to adjust to new information or situations, meaning they can't really pick up new skills or knowledge on their own. This inability to adapt is a major hurdle, especially in real-world applications where circumstances can change so quickly and unexpectedly. For example, if a model is trained to understand a specific type of language or topic, it won't just automatically learn to handle new slang or emerging trends unless it is specifically retrained. So, this can lead to outdated responses or misunderstandings, making the AI less useful in dynamic environments, such as customer service or content creation. So, researchers are working on solutions like self-adapting language models, which aim to tackle these issues directly. So, by improving adaptability, these models could perform so much better in challenging situations, leading to more accurate and relevant outputs. This is a step toward overcoming the limitations of current AI models and making them more effective in real-world applications.
What kind of specific techniques does the SEAL method employ to enable self-adaptation in language models? And how do they differ from traditional training methods?
So the SEAL method employs specific techniques to enable self-adaptation in language models that are quite different from traditional training methods. Imagine teaching a child not only just how to read, but also how to learn new words by themselves. This is what SEAL aims to accomplish with AI. So the process involves two main phases. Training a self-adapter in the first phase. So the focus is on training the model to be a good learner. So this self-adapter is designed to generate new data that helps the model learn effectively. It's like giving the child tools and strategies to discover new words on their own, rather than just memorizing a list, sort of. 2. Real-world learning. After the self-adapter is trained, it is deployed in real-world situations where it can learn continuously and adapt to new information. This is similar to allowing the child to explore a library and pick up new books to read, learning from them as they go. So, a key difference from traditional methods is that SEAL uses techniques like LoRAs, which allow the model to create attachable learning components without changing the core model itself. So this means the model can improve its learning capability without risking its foundational knowledge, making the process scalable and more efficient. So in summary, while traditional methods often require retraining the entire model with new data, SEAL focuses on equipping the model with the ability to learn independently and adapt in real time, leading to a sort of more flexible and capable AI. So,
how does the SEAL method utilize reinforcement learning and self-edits to enhance the learning process? And what kind of impact do these mechanisms have on the model's performance?
So the SEAL method enhances the learning process through mechanisms like reinforcement learning and self-edits, which work together to improve the model's performance. Think of it like teaching a dog new tricks, like you reward the dog for good behavior, helping it learn faster and better. In the first phase, the model is actually trained to be a self-adapter, which means it learns how to select the best data and training methods for new tasks on its own. So, this is similar to a dog, just figuring out which treat works best as a reward for learning a new trick. For example, in a challenging reasoning task, so SEAL's model was able to achieve a success rate of 72.5% by just autonomously choosing the right data to enhance its learning, a dramatic improvement compared to traditional methods that perform poorly. The use of self-edits allows the model to refine its own learning without actually needing to modify the entire base model. This is kind of like allowing the dog to practice a trick repeatedly until it gets it right, but without changing the basic commands you originally taught it. By using LoRAs, the model can test and verify its self-edits before fully committing to them, ensuring that it learns so effectively. Overall, these mechanisms lead to significant performance improvements, allowing the model to adapt and learn in real time, so much like a pet that becomes smarter and more capable through practice and positive reinforcement. So, this approach makes the model not just a learner, but also a self-improving entity capable of tackling new challenges with greater success.
What kind of challenges does the SEAL method face concerning verifiable rewards and catastrophic forgetting? And how did these challenges affect its implementation in practical scenarios?
The SEAL method faces significant challenges related to verifiable rewards and catastrophic forgetting, which can really impact its practical implementation. Imagine trying to teach a child new facts while also making sure they don't just forget what they learned before. Catastrophic forgetting is like the child, like suddenly forgetting their multiplication tables when they start learning about division. So, in the context of SEAL, this means that as the model learns new information, it might lose track of older knowledge, which can lead to less reliable performance over time. Additionally, the reliance on verifiable rewards poses another challenge. Like in traditional reinforcement learning, the model learns from clear feedback, so knowing if an answer is right or wrong. However, in so many real-world scenarios, it's not always possible to determine if a trial was successful. This is akin to just trying to teach the child a new game without knowing the rules or whether they played it correctly. Without a clear measure of success or failure, it becomes so difficult for the model to learn effectively. So these challenges make the implementation of SEAL in practical scenarios more complex. If the model forgets important information or struggles to receive clear feedback, it may not perform as well in dynamic environments where adaptability is so crucial. Overcoming these hurdles is so essential for making the SEAL method truly effective and reliable in real-world applications.
What are some of the implications of the SEAL method's success in increasing performance on benchmarks like the ARC? And how does this advancement contribute to the future development of adaptive AI systems?
So, the success of the SEAL method in increasing performance on benchmarks like the ARC has several really important implications for the future of adaptive AI systems. First, achieving such a dramatic performance increase from virtually no success to a high success rate demonstrates that really self-adapting methods can significantly enhance AI capability. This is like a student who, after struggling with math, suddenly learns to solve complex problems quickly. Such advancements show that AI can become more capable of understanding and tackling really challenging tasks. Second, the ability of SEAL to autonomously select the best data and training parameters means that future AI systems could actually become more efficient learners. This is akin to a student figuring out the best study methods for themselves. So, with this kind of adaptability, AI can potentially learn new information or skills more quickly and effectively, so making them more useful in various applications. Additionally, the success in knowledge incorporation highlights the potential for AI systems to better integrate and utilize information without needing constant supervision or retraining, whatever. So this could lead to more intelligent systems, can provide accurate answers based on evolving data, much like a well-informed friend who stays updated on current events. Overall, these advancements suggest a really promising direction for the development of adaptive AI systems, paving the way for models that can learn and grow in real time, making them more versatile and effective in real-world scenarios. So
how does the SEAL method address the issue of scalability in self-adapting language models? And what benefits does this scalability bring to the deployment of AI in diverse fields?
So the SEAL method addresses the issue of scalability in self-adapting language models by using techniques like LoRAs, which allow for the training of attachable surrogate models without changing the core model itself. So imagine if you could teach a child new skills by adding new tools to their toolbox without having to change who they are. This is similar to how SEAL operates by employing this approach. So SEAL can create a scalable process for teaching models to learn. This means that instead of retraining the entire model every time new information or skills are needed, we can simply add new components that enhance the models, like learning capabilities. This flexibility makes it easier to adapt the AI to different tasks or fields without actually starting from scratch each time. The benefits of this scalability are significant. In diverse fields like healthcare, like finance or customer service, AI systems can quickly adapt to new information, regulations, or user needs. This leads to more efficient and effective deployments, so as the AI can continuously learn and improve in real time. It also allows for faster updates and adjustments, so making the technology more responsive to changes in the environment or requirements. Overall, the scalability provided by the SEAL method enhances the potential for adaptive AI systems to be effectively used across various industries, ensuring they remain so relevant and useful as conditions evolve.
And that brings us to the close of a truly illuminating discussion. Today, we delved into the fundamental limitations of current AI models, recognizing their struggle with adaptability so much like a fixed mechanism, unable to learn from new experiences, so leading to outdated responses in dynamic setting. We then explored how the innovative SEAL method offers a compelling solution. This approach empowers AI to train self-adapting language models through a two-phase process. First, creating independent self-adapters and then deploying them for real-world learning. Techniques like LoRAs are pretty crucial here, allowing models to refine their knowledge without altering their core architecture, which significantly enhances their scalability. While challenges such as catastrophic forgetting and the complexities of verifiable rewards remain, the impressive performance of SEAL on benchmarks so clearly signals its immense potential. So this method promises to enable AI systems to efficiently learn and integrate new information, autonomously, rapidly adapting across various fields, and ultimately making them far more effective and responsive to constantly evolving conditions. So thank you for joining us for this insightful exploration into the future of adaptive artificial intelligence. So we look forward to having you with us again